Trigonometry, Chapter 1, Trigonometric Functions, Section 3, Trigonometric Functions, Video 6, Example 3 of the 6 trigonometric functions. Let's get right into it. Find the 6 trigonometric functions of theta if the terminal side of theta is on the graph of x plus 2y equals 0, where x is greater than or equal to 0. I would be remiss if I didn't mention, or at least point out, that when drawing an angle on a coordinate plane, you should probably draw it in standard position with its initial side on the positive x-axis and the terminal side lying on the graph of x plus 2y equals 0. As far as how you rotate to get from the initial side to the terminal side, it doesn't matter if we go counterclockwise or clockwise or make a bunch of revolutions. I'll take the shortest path and go in the negative direction and say there's theta. Now, in order to find values of the trigonometric functions, we need a point on the terminal side of theta. We know the terminal side of theta lies on the graph of x plus 2y equals 0. X is greater than or equal to 0. So how do we find such a point? Well, to find such a point, we choose a value of x and solve for y. We can choose y and solve for x, but either way will work. Since x is greater than or equal to 0, let's pick x equals 2 to substitute into x plus 2y equals 0. Why didn't I pick x equals 1? Think about it. The equation x plus 2y equals 0 becomes 2 plus 2y is equal to 0. Do you see why I picked 2 for x now? Subtract 2 from both sides to get 2y equals negative 2. You should really see why I picked 2 for x now. Divide both sides by 2 to get y equals negative 1. I anticipated dividing by 2 as my last move, so I used a value of x that was divisible by 2. It's not that I'm scared of decimals, but why if I can avoid it? Now we have x equals 2 and y equals negative 1. So r, the distance from the point to the origin, is the square root of the square of the x plus the square of the y, which gives us the square root of 5. Hence, we can set up our trig functions. Again, here you see all 6 definitions, which you need to know. And substituting 2 for x, negative 1 for y, and the square root of 5 for r gives us this. And then be able to look out for things to clean up, such as the negative inside the fraction and the square root in the denominator for sine of theta, square root in the denominator for cosine of theta, negative in the numerator for tangent of theta. We're dividing by 1, or negative 1 for cosecant of theta. Secant theta is the only one that looks good as is, square root of 5 over 2. But cotangent of theta is 2 over negative 1, and that can clearly be cleaned up. So cotangent should become negative 2. Tangent should become negative 1/2. Cosecant should become negative square root of 5. As far as sine and cosine, we need to rationalize the denominator, or at least your professor or online homework platform might require you to do that. And if you did that, let me go back one. For sine of theta and cosine of theta, you would multiply both sides of each fraction by the square root of 5 over 5. Excuse me, the square root of 5 over the square root of 5. And the result in cleaning everything up would be sine of theta equals negative square root of 5 over 5. Cosine of theta equals 2 square root of 5 over 5. Tangent theta equals negative 1/2. Cosecant theta equals negative square root of 5. Secant theta equals square root of 5 over 2. And cotangent theta equal negative 2. Come on. Now, there is an important observation to make about the angle determined by the equation x plus 2y equals 0 and the value of one of the trigonometric functions. In order to make that observation, I would like to find the slope of this line. From algebra, we know that the equation y equals mx plus b is called slope-intercept form. The slope of the line is m, and the y-intercept is the ordered pair 0, b. If we solve x plus 2y equals 0 for y, and hence put it in slope-intercept form, we'd get y equals negative 1/2 x. And this line has a slope of negative 1/2. Now recall the values of the trig functions on the angle theta determined by the line x plus 2y equals 0. And notice that tangent is negative 1/2 right here. Just like the slope was -1/2. Coincidence? Hardly. It's not a coincidence that the slope of the line equals the tangent of the angle formed by the line and the x-axis. In general, if the line y equals mx plus b forms an angle of measure theta with the x-axis, then m equals tangent of theta. But can you figure out why? Draw a picture, I bet you can figure it out. All right, now you try. Pause the video and try the following problem. Find the 6 trigonometric functions of theta. If the terminal side of theta is on the graph of 3x plus y is equal to 0 and x is less than or equal to 0. Pause the video, give it a try. All right, here's your friendly warning. Last chance to pause the video and try the question. Solutions in 3, 2, 1. If we let x equal -1 in the equation, we can solve to get y equals 3, and subsequently r is the square root of 10. Then we can set up all 6 trig functions, simplifying answers as necessary. Looks like the only answer that didn't need any sort of simplification was cosecant of theta.